Imagine walking into a natural history museum and staring up at a massive dinosaur skeleton. You're looking at millions of years of evolution, perfectly reconstructed by brilliant scientists who spent decades piecing together ancient mysteries. Except there's one tiny problem. Half of what you're looking at is probably wrong, dead wrong, and the other half might be mounted backwards. Welcome to the wild world of paleontology, where even the smartest people on Earth can spend entire careers getting prehistoric creatures spectacularly, embarrassingly, hilariously incorrect. We're talking about mistakes so bad they make your worst exam answers look like genius-level insights. Scientists have confused heads with tails, turned peaceful plant eaters into bloodthirsty monsters, and somehow convinced themselves that creatures with razor-sharp claws were gentle fruit enthusiasts. But here's the thing that'll absolutely blow your mind. These weren't just innocent little oopsies. These mistakes sparked legendary feuds, rewrote textbooks for decades, and created myths that still haunt popular culture today. Some of these scientific blunders were so spectacular that they literally changed how we see the ancient world. And the best part, we're definitely making the exact same mistakes right now with fossils sitting in museums around the globe. Future scientists are going to look back at our reconstructions and laugh until their sides hurt. So buckle up, because we're about to dive into the most epic fails in scientific history. These are the stories of brilliant researchers who got prehistoric creatures so wrong that it's actually impressive. We're talking about mix-ups so legendary they make reality TV drama look boring. Let's start with one of the most embarrassing moments in paleontology history. Picture this scene. You're a respected scientist in the late 1800s, and you've just made the discovery of a lifetime. You've found the fossil of a massive marine reptile unlike anything the world has ever seen. This thing is enormous, stretching out to an incredible 40 feet of prehistoric nightmare fuel. You can practically taste the fame and recognition coming your way. So you do what any reasonable scientist would do. You carefully excavate every bone, meticulously study each fragment, and begin the painstaking process of reconstruction. Months pass. You double-check your work, consult with colleagues, and finally present your findings to the scientific community with absolute confidence. There's just one teensy-tiny, absolutely mortifying problem. You've put the entire creature together backwards. The head is where the tail should be, and the tail is where the head should be. Congratulations! You've just created the paleontological equivalent of trying to drive a car while sitting in the trunk. This actually happened to a guy named Edward Cope, and it launched one of the most vicious scientific feuds in history. Cope was brilliant, respected, and absolutely convinced he'd found something revolutionary. The fossil he discovered had an impossibly long section of vertebrae, longer than anything anyone had ever seen before. We're talking about 72 individual neck bones stretching out like some kind of prehistoric accordion. Now, here's where Cope's brain just completely short-circuited. Nobody had ever found a reptile with a neck this ridiculously long. It seemed physically impossible. So Cope made what seemed like a logical decision at the time. Those 72 vertebrae couldn't possibly be a neck. Obviously, they had to be the tail. The short section on the other end, that had to be the neck. Head goes on the short end. tail goes on the long end. Elementary logic, right? Wrong. So incredibly spectacularly wrong. Cope published his findings, created detailed drawings, gave lectures, and basically showed off his backward sea monster to anyone who would listen. He was riding high, probably already planning his acceptance speech for whatever scientific awards were coming his way. Enter Daniel Marsh, Cope's biggest rival and the kind of person who probably corrected people's grammar at dinner parties. Marsh took one look at Cope's reconstruction and just lost it. We're not talking about polite scientific disagreement here. Marsh started full-blown laughing, tears streaming down his face, because Cope had mounted a 40-foot marine reptile with its head on completely backwards. The humiliation was instant and brutal. Marsh made sure everyone in the scientific community knew about Cope's little mix-up. Academic conferences turned into roast sessions. Scientific journals became gossip magazines. This one mistake launched what historians now call the Bone Wars. Basically, a decades-long feud between two grown men who really should have known better. But here's the thing that'll make your head spin. This backwards head incident wasn't even the weirdest case of scientists getting prehistoric creatures totally wrong. Because wait until you hear about the spiral of death that stumped experts for over a century. Picture finding a perfect spiral of razor-sharp teeth and having absolutely no clue what animal they came from. That's exactly what happened when scientists first discovered something called Helicoprion back in 1899. They stared at this thing for months, turned it upside down, held it up to the light, rotated it every possible direction, and came up with absolutely nothing. At first, they thought it might be some kind of shell. You know, like those spiral snail shells you find at the beach? Completely reasonable guess except for one minor detail. Shells usually aren't made of teeth specifically designed to slice through flesh. If this thing was a snail, it was basically nature's version of a circular saw, except that circular saw was made entirely of razor blades. Once they figured out it was actually a mouthful of nightmares, the real fun began. Scientists spent the next 100 years playing the world's most disturbing game of pin the tail on the donkey. Except instead of a tail, it was a buzzsaw made of teeth. And instead of a donkey, it was some unknown prehistoric monster that probably haunted the dreams of ancient fish. The first theory was that it had to be a nose saw. Obviously, this creature had a circular saw sticking out of its face like some kind of prehistoric power tool. That makes perfect sense, right? Terrifying, but logical. When that didn't work out, they tried mounting it on the tail. Maybe it was some kind of defensive weapon, like a medieval flail, but with more teeth and significantly worse intentions. Still looked ridiculous. So they tried putting it on the back, like a dorsal fin made of pure nightmare fuel. That didn't work either. For over 100 years, scientists kept moving this death spiral around, trying to find where it belonged on the creature. Museums had to keep updating their displays. Textbooks got rewritten every decade. Kids probably thought prehistoric sharks just had random buzz saws attached to various body parts, depending on which museum they visited. The poor creature looked different in every single reconstruction. Sometimes it had the saw nose, making it look like a prehistoric swordfish, that had gotten way too aggressive. Sometimes it was tail-powered, like nature's version of a helicopter. One version made it look less like a fearsome predator and more like a rejected villain from a children's cartoon show. Then 2013 happened, and CT scans finally revealed the truth. And it was way weirder than anyone had guessed. The spiral wasn't sticking out of the animal at all. It was hidden inside the throat, working as some kind of organic meat slicer. Basically, this thing had a built-in food processor in its mouth. But even that discovery pales in comparison to what Soviet scientists thought they'd found when they discovered some 3-foot-long claws in the Mongolian desert. Finding claws that big could only mean one thing, right? Giant turtle. At least, that's what Soviet scientist Yevgeny Malayev decided in the 1950s. He took one look at those massive talons and thought, obviously, this thing lived in the ocean and used these claws to harvest seaweed. You know, normal turtle stuff. Just your average, everyday giant sea turtle with claws longer than baseball bats, peacefully gardening underwater like some kind of prehistoric landscaper. Malayev was so confident in his turtle theory that he created an entire new family of turtles just for this creature. He called it Therizinosaurus, which means reaping lizard. Apparently, even the name had to sound like farming equipment. The whole scientific community just went along with it. Nobody questioned whether maybe, just maybe, a turtle with 3-foot claws might be designed for something other than delicate salad preparation. Textbooks got updated. Museums built displays. For 25 years, everyone agreed that somewhere in prehistoric oceans there swam a turtle the size of a school bus with claws that could slice through steel, and it spent its days gently harvesting aquatic vegetation like the world's most terrifying gardener. Think about that for a second. Grown adults with advanced degrees looked at claws longer than your arm and decided they belonged to something that eats plants underwater. That's the scientific process at work, folks. The turtle theory finally died in the 1980s, when paleontologists found more bones and realized their mistake. Turns out Therizinosaurus wasn't a turtle at all. Shocking development, I know. It was actually a dinosaur, a theropod to be precise. The same group that gave us T-Rex and Velociraptor, except this one decided to go full vegetarian instead of terrorizing other dinosaurs. Those 3-foot claws weren't for harvesting seaweed. They were for pulling down tree branches and maybe convincing other dinosaurs to mind their own business. And here's the kicker. The Therizinosaurus probably had feathers. So we went from imagining a giant turtle swimming around the ocean to a 30-foot tall feathered dinosaur that looked like Big Bird's absolutely terrifying cousin. 25 years of being completely wrong about something, all because someone couldn't imagine claws that big on anything except a turtle. Speaking of getting the basic animal completely wrong, let's talk about the king lizard that ruled ancient seas. Basilosaurus means king lizard, which is awkward because it's actually a whale. But we're stuck with the name forever because of scientific red tape and the unfortunate reality that whoever finds it first gets to name it, even if they're spectacularly wrong. Back in 1834, Richard Harlan found these massive fossil bones in Alabama and immediately thought giant sea serpent. He slapped the name Basilosaurus on it and called it a day. 5 years later, Richard Owen examined the same bones and noticed something weird. The teeth had two roots. Reptiles don't have two-rooted teeth. Mammals do. Owen tried to fix the mistake. He suggested renaming it Zeuglodon, which actually meant whale. But science has rules about this stuff. First name wins, even if it's completely wrong. So now we have an 80-foot whale named King Lizard swimming around the history books, and there's absolutely nothing anyone can do about it. The whole lizard thing made sense at first glance. Basilosaurus was huge and serpentine with a tiny head. It looked exactly like what you'd expect from a prehistoric sea monster. Museums mounted it with flippers in the wrong places. Artists drew it breathing fire. Kids probably had nightmares about the king lizard coming to eat them. Nobody wanted to admit they'd been calling a whale a lizard for decades. Even after the evidence piled up, some scientists kept insisting it had to be some kind of reptile, because apparently changing your mind is harder than defying basic biology. The real Basilosaurus was actually terrifying in completely different ways. This thing didn't breathe fire or crush ships like some mythical sea serpent. It hunted other whales. Fossil evidence shows Basilosaurus' stomach contents included smaller whales that had been swallowed whole. Imagine being a whale and getting eaten by something called king lizard. That's just adding insult to injury. And here's the funniest part. Basilosaurus still had tiny back legs, useless little flippers hanging off its rear end that served no purpose except to remind everyone that whales used to walk on land. That's evolution's way of keeping receipts. But at least they got the basic animal right, unlike the gentle giants that apparently spent their whole lives standing around in swamps. For 50 years, everyone knew exactly how Brontosaurus lived. These massive creatures spent their days lounging in prehistoric lakes because they were obviously too heavy for dry land, and they used their long necks as snorkels. It made perfect sense to the scientific community. Something that weighs 30 tons can't possibly walk around on solid ground without sinking into the earth like quicksand. Water would support all that weight. Plus, look at that neck. It's clearly designed for breathing while submerged up to the eyeballs. Museums built entire exhibits around this idea. Artists painted countless pictures of herds of Brontosaurus hanging out in prehistoric lakes, necks sticking up like periscopes. Kids grew up thinking dinosaurs were basically really big hippos who couldn't be bothered to leave the pool. Charles R. Knight painted the definitive Brontosaurus scene in 1897, and it's standing chest deep in water, looking completely at home. That painting influenced how people saw dinosaurs for decades. Lazy giants who spent their lives in permanent pool parties because walking was apparently too much effort. There was just one small problem with this whole theory. Physics. Water pressure increases as you go deeper. Everyone knows this. You feel it in your ears when you dive to the bottom of a swimming pool. Now imagine being a 30-ton animal trying to breathe through a tube while your chest is being squeezed by tons of water pressure. Your lungs would collapse instantly. You'd suffocate before you could take a single breath. But nobody thought about this for half a century. Scientists just accepted that these dinosaurs lived underwater because the alternative seemed impossible. When researchers finally tested the theory, they realized Brontosaurus could absolutely support its weight on land. Their leg bones were thick and strong. Their feet were wide and padded. Everything about their build screamed land animal. The neck that everyone thought was a snorkel was actually used to reach the tops of tall plants. And that tail everyone drew dragging behind them like a wet rope. They held it up off the ground, probably using it for balance and as a weapon against anything stupid enough to attack a 30-ton herbivore. Even the name was wrong for decades. Scientists spent years arguing whether Brontosaurus was actually different from Apatosaurus. Spoiler alert, it probably is, but that's a whole other mess of scientific confusion. But at least they didn't spend 60 years calling it a baby-eating monster. Right now, in the New York City subway system, there's a mosaic showing a dinosaur called Coelophysis eating its own baby. It's been there for decades. Thousands of people see it every day. But it's completely wrong. This whole cannibalism thing started in the 1950s when Edwin Colbert found a mass grave of Coelophysis skeletons at Ghost Ranch, New Mexico. Hundreds of these little dinosaurs had died together, probably from drought or flooding. Inside the rib cage of two adults, Colbert found small bones. His conclusion: these dinosaurs had been snacking on their own kids right before they died. Case closed. The story spread everywhere. Textbooks included gruesome illustrations of adult Coelophysis tearing apart juveniles. Museums put up displays about dinosaur cannibalism. Scientists wrote papers about this aberrant behavior. For 60 years, Coelophysis was the poster child for prehistoric family dysfunction. Nobody bothered to double-check the evidence until 2006, when researchers finally took another look at those Ghost Ranch fossils. They found two major problems with the cannibalism theory. Problem one, the gut contents weren't actually inside the stomach. The bones were underneath the adult skeleton. The bigger dinosaur had just fallen on top of a smaller one, which is death by crushing, not death by eating. Problem two, the small bones weren't even from baby Coelophysis. One was from an early crocodile. The others were too big and the wrong shape to be Coelophysis babies. So what actually happened? An adult Coelophysis ate a small crocodile for lunch, then died in a mass extinction event. Normal predatory behavior, not family cannibalism. The correction got published in scientific journals. Researchers updated their papers. The cannibalism theory officially died, but that subway mosaic is still there. Textbooks still mention it sometimes. The internet is full of cannibal dinosaur articles that never got updated. Changing public perception takes forever, even when science corrects itself. Coelophysis went from normal little predator to baby-eating monster and back to normal predator, all because someone misidentified lunch as infanticide. And that brings us to one of the longest-running debates in paleontology history. Scientists spent 120 years arguing about where one reptile lived, not what it ate, not how it reproduced, not even what it looked like, just whether it spent its time on land or in the water. This became paleontology's longest-running debate, and it all started with something called Tanystropheus and its absolutely ridiculous neck. This thing's neck was 3 times longer than the rest of its body combined. Imagine if your neck was suddenly 18 feet long while the rest of you stayed the same size. That's what we're dealing with here. A creature that looked like someone had taken the normal lizard and stretched it through some kind of prehistoric taffy machine. When researchers first found Tanistropheus fossils back in the 1800s, they didn't even know what they were looking at. Some thought the neck bones came from a flying reptile that had somehow lost its wings. Others assumed they belonged to multiple different animals that just happened to die in the same spot, like some kind of ancient traffic accident. Once they figured out it was all one creature, the real arguments began. Team Land said it lived on shore and used its incredibly long neck to reach into water and grab fish. Think of it like a giraffe, but instead of eating leaves from tall trees, it was fishing with the world's most inconvenient fishing rod attached to its head. Team Water insisted it was fully aquatic. The neck would stick up above the surface, while the body stayed hidden underwater, waiting to ambush unsuspecting prey. Like a prehistoric periscope, but with teeth and significantly worse intentions. Both teams had serious problems with their theories. The land people couldn't explain how something with such a long, stiff neck could walk around without constantly falling over like a drunk person trying to navigate an obstacle course. The water people couldn't figure out how it would swim efficiently with that giant neck creating massive drag, like trying to swim while towing a telephone pole behind you. For decades, textbooks would flip-flop their position depending on which scientist wrote them. Museums kept updating their displays every few years. Kids probably learned 5 different things about where Tanistropheus lived depending on what year they happened to visit the Natural History Museum. The whole debate finally ended in 2020 when CT scans revealed some crucial details. Tanistropheus had nostrils positioned on top of its head and teeth specifically designed for catching slippery prey. Classic aquatic adaptations. The neck wasn't for reaching up to breathe like everyone thought. It was for stealth hunting underwater. The body would stay perfectly motionless in shallow water while that impossibly long neck slowly moved into position. No ripples, no movement, just a head appearing out of nowhere to grab unsuspecting fish. It only took them 120 years to figure out that the giant neck was basically nature's version of a sniper rifle. Meanwhile, other scientists were busy convincing themselves that bone-crushing jaws meant a vegetarian diet. Meet Thylacoleo, an animal that had teeth designed to crush bone and claws that could slice through steel. Naturally, scientists decided it was a gentle fruit enthusiast who spent its days peacefully munching on prehistoric melons. This made perfect sense to them at the time. Sure, it had the strongest bite force of any mammal ever discovered. And yes, those retractable thumb claws were perfectly designed for ripping flesh apart like organic switchblades. But it was a marsupial, and marsupials just weren't supposed to be apex predators in the minds of early researchers. Richard Owen first described Thylacoleo back in 1859 and correctly identified it as a carnivore. He looked at those massive slicing teeth and those bear-trap jaws and said, yeah, this thing definitely killed stuff for a living. Pretty obvious conclusion when you think about it. But other scientists weren't having it. They took one look at Thylacoleo's dental arrangement and declared it was obviously adapted for cracking nuts and processing tough plant material. Those huge premolars weren't for shearing meat, they insisted. They were nature's version of industrial-strength nutcrackers. For 150 years, scientific papers went back and forth on this ridiculous debate. Team Carnivore would publish evidence of meat-eating adaptations, and Team Vegetarian would publish rebuttals about fruit processing teeth. Museums couldn't even decide how to display the thing. Some showed Thylacoleo stalking prey with its massive claws extended like some kind of prehistoric assassin. Others showed it peacefully munching on ancient produce like the world's most overbuilt grocery shopper. The whole argument was frankly absurd. This animal had forward-facing eyes specifically designed for judging distance when attacking prey. It had powerful forelimbs built for wrestling down large animals. Everything about Thylacoleo screamed apex predator. But the fruit-eating theory persisted because scientists had preconceived notions about what marsupials could and couldn't do. Cave evidence finally settled the debate in 2016. Researchers found claw marks showing Thylacoleo could climb rock faces to ambush prey from above like some kind of prehistoric ninja. They also discovered bite marks on ancient kangaroo bones that matched Thylacoleo's teeth perfectly. So much for the melon-munching marsupial theory. Thylacoleo was officially recognized as Australia's premier predator, capable of taking down animals twice its size. Sometimes the obvious answer really is the right one, even when it challenges what stubborn scientists want to believe. And speaking of challenging beliefs, Charles Darwin faced the exact same problem with his weirdest discovery in South America. Darwin found something called Macrauchenia in 1834 and immediately regretted it. Not because it wasn't fascinating. The thing was absolutely incredible. It had a camel-sized body, horse-like legs, what appeared to be an elephant trunk, and feet that looked like they belonged on something completely different. Darwin just had no clue what he was looking at. This drove him absolutely nuts. Here's the guy who would eventually figure out how all life on Earth evolved, and he couldn't even classify one weird fossil from Argentina. Darwin wrote desperate letters to other scientists asking for help. He described every single bone in excruciating detail, and nobody had any answers. Scientists spent the next 180 years playing Guess the Animal with Macrauchenia. First, they stuck it with the camels. Made perfect sense. Similar size, long neck, lived in South America, where llamas and alpacas hang out today. That didn't work. The teeth were completely wrong. The feet were wrong. The skull had those weird nasal openings way up on the forehead, suggesting some kind of trunk situation. So they tried elephants next. The trunk thing seemed obvious, right? Plus, it was big and heavy enough to be related to prehistoric elephants. But nope, wrong teeth again. Everything kept pointing back to camels, then horses, then back to elephants in an endless cycle of scientific confusion. Scientists kept moving Macrauchenia around the family tree every few decades, hoping something would eventually stick. Museums had to constantly update their displays. Textbooks got rewritten over and over. Kids learned completely different things about what Macrauchenia was related to, depending on what decade they happened to be in school. The whole mystery finally got solved in 2017 when scientists managed to extract actual DNA from Microchenia bones. Ancient DNA is incredibly rare, so this was absolutely huge. And the results were mind-blowing. Microchenia was most closely related to horses and rhinos, not camels, not elephants, not anything anyone had guessed for nearly 2 centuries. It had split off from the common ancestor about 66 million years ago and evolved completely separately in South America. No wonder nobody could place it in the family tree. It was literally the last member of an entire group of animals that had no living relatives anywhere else on Earth. Darwin's fossil that stumped everyone for generations was genuinely one of a kind. But size can create just as much confusion as weird anatomy. Let's talk about the massive teeth that accidentally sparked Bigfoot legends. Giant molars started showing up in Chinese pharmacies during the 1930s. The shopkeepers called them dragon bones and sold them as traditional medicine because apparently grinding up prehistoric teeth was considered good for your health. Ralph von Koenigswald walked into one of these shops, took one look at these enormous teeth, and realized they came from the largest primate that had ever lived. These things were absolutely massive, easily double the size of gorilla teeth. Whatever creature they came from had to be at least 10 feet tall when standing upright. Early researchers immediately started wondering if this was some kind of prehistoric human ancestor. The idea caught fire fast. If giant humanoid primates had lived in Asia until relatively recently, maybe some of them had survived into modern times. Maybe they were still out there somewhere. Maybe people weren't completely crazy when they reported seeing Bigfoot or the Yeti. Cryptozoologists went absolutely wild. Here was potential scientific evidence that giant human-like creatures had actually existed. The whole Bigfoot phenomenon got a major boost from these discoveries. Scientists couldn't agree on what it looked like, though. Some imagined a 10-foot-tall gorilla walking upright through Asian forests. Others pictured something more human-like but covered in thick fur. Everyone agreed it was absolutely massive and probably walked on 2 legs most of the time. Museums built displays showing giant ape men roaming prehistoric Asia. Books featured artwork of enormous humanoid creatures that looked ready to star in monster movies. But there was just one problem with all these theories. They were based entirely on teeth and jaw fragments. Nobody had found any other bones at the time, so everything was basically educated guesswork based on dental evidence. When researchers finally got more complete fossil evidence, the giant human ancestor theory completely collapsed. Gigantopithecus was definitely an ape, closely related to orangutans actually, and it probably moved around on all 4s when it bothered to move at all. And what did this 10-foot monster eat? Plants, specifically bamboo. Lots and lots of bamboo. So much for the terrifying giant human ancestor theory. Gigantopithecus was more like a supersized panda, huge and plant-eating, and probably too lazy to chase anything that moved faster than a gentle breeze. But the real giant human story was actually happening in Europe at the same time, with much smaller bones and an even bigger impact on popular culture. Every single caveman costume you've ever seen is based on one elderly guy with really bad arthritis. Marcelin Boule examined a Neanderthal skeleton in 1911 and decided these ancient humans were bent-kneed, knuckle-dragging brutes who shuffled around caves grunting at each other like prehistoric zombies. His description became the official scientific position for 60 years and basically created every caveman stereotype that still exists today. Textbooks showed stupid-looking primitive humans. Museums built displays of dim-witted early people who could barely walk upright. Hollywood made movies about club-wielding Neanderthals who seemed more ape than human. The whole brutish caveman image entered popular culture and never left. Even today, calling someone a Neanderthal means they're stupid and primitive, which is incredibly unfair when you consider what we actually know about them now. But there was one tiny detail Boule missed. The skeleton he studied belonged to an old Neanderthal with severe arthritis. The bent spine and worn joints weren't normal anatomy. They were signs of an elderly individual with serious joint disease. Boule basically looked at one really old guy with back problems and concluded that's how an entire species normally looked. It would be like future archaeologists finding the skeleton of someone with advanced osteoporosis and deciding that all early 21st century humans walked around permanently hunched over. By the 1950s, other scientists started pointing out the obvious problems with this theory. They re-examined the skeleton and found clear evidence of pathological conditions. If this Neanderthal walked with bent knees, it was because of arthritis, not evolution. But the damage was done. The bent-knee caveman image had spread everywhere, and scientific corrections don't make for good movie plots or Halloween costumes. Modern research shows Neanderthals actually stood completely upright, just like us. They had brains as large as ours, sometimes larger. They made sophisticated tools, controlled fire, and buried their dead with flowers and personal belongings. They created jewelry, painted cave walls, and had complex social structures. They probably spoke languages as advanced as early modern humans. Most Neanderthal sites aren't even in caves. They're outdoor camps near rivers and hunting grounds. The whole cave-dwelling thing was just preservation bias because bones survive better underground. And here's the really interesting part. We actually interbred with them. People of non-African ancestry carry Neanderthal DNA in their genes right now. Our ancestors thought Neanderthals were attractive enough and similar enough to have children with them. So ultimately, one arthritic skeleton created a stereotype that lasted over a century and still influences how we see ancient humans today. One old guy with joint problems became the template for every caveman representation in popular culture. And that's the real lesson here. Sometimes the biggest scientific mistakes become the hardest myths to kill, and they can seriously damage public understanding of what prehistoric life was actually like. The funny thing is, we're definitely making similar mistakes right now. Somewhere in a museum, there are probably dozens of fossils mounted incorrectly or interpreted wrong, all because we don't have enough information yet to understand what these creatures were really like. But wait, there's more. Because while we're laughing at all these historical blunders, there's another group of creatures that scientists managed to get so spectacularly wrong that it makes everything we've talked about so far look like minor typos. We're talking about mistakes so fundamental that they literally created entirely new categories of imaginary animals. Meet the bone-headed dinosaurs that weren't actually bone-headed at all. For decades, paleontologists were absolutely convinced they'd discovered a group of dinosaurs that used their thick skulls as battering rams. These creatures, called Pachycephalosaurus, supposedly spent their days head-butting each other like prehistoric football players having the world's most violent scrimmage. The theory made perfect sense. Look at those skulls. They're ridiculously thick, sometimes nearly a foot of solid bone. What else could that possibly be for except ramming into things? Scientists created detailed models showing how these dinosaurs would charge at each other, skulls first, in epic battles for dominance. Museums built displays featuring Pachycephalosaurus locked in head-to-head combat. Nature documentaries showed dramatic reenactments of bone-crushing collisions that would make NFL highlight reels look tame. Kids grew up thinking these dinosaurs were basically living wrecking balls with legs. But then someone actually bothered to study the physics involved, and the whole theory fell apart faster than a house of cards in a hurricane. Turns out, if these dinosaurs really did spend their time ramming skulls together, they'd give themselves catastrophic brain damage within minutes. The force of impact would be so severe that it would literally scramble their brains like prehistoric eggs. Computer simulations showed that even with those thick skulls, the shock waves from impact would travel straight through the bone and turn their neural tissue into jelly. These weren't battering rams. They were probably just display structures like peacock feathers, but made of bone instead of pretty colors. So we went from imagining dinosaurs engaged in gladiatorial skull-smashing contests to creatures that probably just showed off their fancy headgear to attract mates. Less exciting, maybe, but significantly more survivable from an evolutionary standpoint. And speaking of display structures, let's talk about the terror birds that apparently weren't all that terrifying. Forus racos was supposed to be South America's ultimate predator, a giant flightless bird that stood 8 feet tall and terrorized everything in its path. Scientists looked at its massive beak and powerful legs and declared it the apex carnivore of its ecosystem. For over a century, everyone agreed that Forus racos was basically a feathered nightmare, using its enormous beak to crush bones and its incredible speed to chase down prey across the prehistoric landscape. It was the stuff of paleontological horror stories. A bird so dangerous it could probably take on a small dinosaur and win. But recent analysis of its skull structure revealed some embarrassing problems with this theory. That massive beak that looks so terrifying, it was actually pretty fragile. The bone structure suggests it would break under the stress of attacking large, struggling prey. Instead of being bone-crushing predator, Forus racos probably used its beak more like a precision instrument for catching smaller animals. We're talking about a bird that went from being South America's most feared predator to something more like a really big, really fast chicken with anger management issues. Still impressive, but not exactly the prehistoric monster everyone thought they'd discovered. Then there's the case of the dinosaur that spent 130 years being two different animals at the same time. Brontosaurus and Apatosaurus were supposed to be completely separate species, distinct enough that they got different names and different spots in the family tree. Museums displayed them as different dinosaurs. Textbooks taught kids about their unique characteristics, but it turns out they were probably the same animal all along. The whole confusion started because paleontologists in the late 1800s were basically in a fossil-finding frenzy, discovering new species left and right, without always checking their work properly. Someone found what they thought was a new type of long-necked dinosaur, gave it the name Brontosaurus, and everyone just went with it. Decades later, other scientists realized that Brontosaurus specimens were basically identical to Apatosaurus specimens that had been found earlier. According to scientific naming rules, the first name wins. So Brontosaurus technically didn't exist anymore. It got relegated to scientific history as a case of mistaken identity, except that recent research suggests maybe they really were different species after all. So now we've gone full circle, from one species to two species back to one species, and possibly back to two species again. It's like watching paleontologists play the world's most confusing shell game with dinosaur names. But at least those mix-ups were about creatures that actually existed. Let's talk about the animals that were completely fabricated from mismatched parts. The Cardiff giant of paleontology, if you will. Scientists in the early 1900s discovered what they thought was a spectacular new species of early horse. They called it Eohippus, and it became the poster child for evolutionary transition. This tiny, dog-sized creature was supposed to show how modern horses evolved from much smaller ancestors. It had the right number of toes, the right body proportions, and lived at exactly the right time in Earth's history. Textbooks featured Eohippus prominently in evolutionary charts. Museums built entire exhibits around it. There was just one small problem. The skeleton was assembled from bones that came from completely different animals. The skull belonged to one species, the body to another, and the legs to yet another. It was like creating a new animal by combining parts from a cat, a dog, and a hamster, then declaring you'd discovered the missing link in mammalian evolution. The mistake wasn't discovered until decades later, when more complete fossils revealed what these animals actually looked like. Eohippus, as originally reconstructed, never existed. It was a scientific Frankenstein's monster, assembled from random parts that happened to be found in the same rock formation. And this brings us to one of the most persistent myths in paleontology, the idea that dinosaurs were cold-blooded, sluggish creatures that spent most of their time lying around in the sun like giant prehistoric lizards. This image dominated scientific thinking for over a century and still influences how many people picture dinosaurs today. The cold-blooded theory seemed logical. Dinosaurs were reptiles, and reptiles are cold-blooded, so obviously dinosaurs must have been slow, sluggish creatures that needed external heat sources to function. They probably spent their mornings basking in the sun, waiting for their body temperature to rise enough for basic movement. Scientists calculated how long it would take a brontosaurus to warm up in the morning sun. Hours, maybe even most of the day. These creatures were supposedly so dependent on external heat that they could barely function during cooler weather. Winter would have been a months-long period of near hibernation. But this theory created some serious problems when people actually thought about it. How does a cold-blooded animal weighing 30 tons get enough external heat to maintain body temperature? The surface area to volume ratio doesn't work. Large animals actually have trouble getting rid of excess heat, not generating enough of it. And what about the dinosaurs living in polar regions? Fossil evidence shows dinosaurs thrived in areas that were cold, even during the Mesozoic era. How does a cold-blooded giant survive an Arctic winter when there's no sun for months at a time? The breakthrough came when scientists started studying dinosaur bone structure under microscopes. The bones showed rapid growth patterns and complex blood vessel arrangements that looked exactly like what you'd find in warm-blooded animals. These weren't sluggish reptiles. They were active, energetic creatures with metabolisms more like modern birds and mammals. Suddenly, everything made more sense. Dinosaurs could live in cold climates because they generated their own body heat. They could grow to enormous sizes because their metabolism could support it. They could be active predators and complex social animals because they had the energy budget for sophisticated behaviors. We went from imagining dinosaurs as oversized lizards to recognizing them as the evolutionary ancestors of some of the most energetic animals on Earth today. Birds are literally living dinosaurs, and anyone who's ever watched a hummingbird hover knows these animals are anything but sluggish. But perhaps the most embarrassing case of scientific stubbornness involves an animal that was staring researchers in the face for over 80 years before anyone bothered to look at it properly. Carnotaurus, the meat-eating bull, was discovered in Argentina in 1985, but similar fossils had been sitting in museum collections since the early 1900s. For 8 decades, these fossils were classified as belonging to various other dinosaur species. Nobody paid much attention to the weird skull fragments and unusual arm bones. They just got filed away in storage rooms and forgotten about. When paleontologists finally took a closer look in the 1980s, they realized they'd been sitting on one of the most bizarre predatory dinosaurs ever discovered. Carnotaurus had horns like a bull, arms so reduced they made T-Rex look well-equipped, and legs built for incredible speed. This wasn't just another generic meat-eating dinosaur. This was a specialized pursuit predator, probably capable of running down prey at speeds that would make a racehorse jealous. The skull was designed for ramming attacks. The legs were pure muscle and speed, and those tiny arms had apparently evolved to be completely useless for anything except maybe scratching itches. 80 years of sitting in storage because nobody bothered to examine the fossils carefully enough to realize they'd found something completely unique. It makes you wonder, what other incredible discoveries are currently gathering dust in museum basements because someone filed them under the wrong category decades ago? And that brings us to the most recent addition to paleontology's Hall of Shame. The dinosaur that was assembled upside down for nearly 20 years. Therizinosaurus, which we mentioned earlier as the giant turtle that wasn't a turtle, had its own reconstruction problems even after scientists figured out it was actually a dinosaur. The first attempts at mounting Therizinosaurus skeletons in the 1990s created a creature that looked like it was perpetually doing some kind of bizarre yoga pose. The spine curved in impossible directions. The legs were positioned at weird angles, and the whole thing looked like it would fall over if someone breathed on it too hard. Museum visitors would stare at these displays and wonder how this animal possibly survived long enough to evolve, let alone thrive in its ecosystem. It looked less like a functional creature and more like the result of someone trying to assemble IKEA furniture without reading the instructions. The problem was that paleontologists had been mounting the vertebrae upside down. The natural curve of the spine was inverted, creating a creature that defied basic principles of anatomy and biomechanics. When researchers finally figured out the correct orientation in the 2010s, Therizinosaurus transformed from an anatomical impossibility into an elegant, well-designed herbivore. The corrected skeleton shows an animal that was perfectly adapted for its lifestyle, with a spine curved in exactly the right direction for reaching high vegetation and a body plan that made perfect sense for a giant plant eater. 20 years of displaying an impossible creature because nobody double-checked which way the bones were supposed to point. But here's what's really wild about all these mistakes. They're not just embarrassing footnotes in scientific history. They've shaped how entire generations of people understand the prehistoric world. Kids who grew up seeing those backwards reconstructions probably still picture some of these animals incorrectly. And the scary part is that we're almost certainly making similar mistakes right now with fossils that haven't been properly studied yet. There are probably dozens of creatures in museums around the world that are mounted incorrectly, classified wrong, or misunderstood in ways that will seem obvious to future paleontologists. The difference is that now we have better technology. CT scanners can reveal internal bone structure without damaging fossils. Computer modeling can test whether reconstructions actually make biomechanical sense. DNA analysis can sometimes tell us about relationships between extinct species that morphology alone couldn't reveal. But technology only helps if people use it properly and ask the right questions. And human nature hasn't changed much since the 1800s. Scientists are still capable of falling in love with their own theories, ignoring contradictory evidence, and making assumptions based on incomplete information. The real lesson from all these paleontological blunders isn't that scientists are incompetent. It's that science is hard. Prehistoric life was weird beyond imagination, and our understanding of ancient ecosystems is constantly evolving as we discover new evidence and develop better analytical techniques. Every mistake we've talked about today eventually got corrected because that's how science works. Someone always comes along with better tools, fresh eyes, or new evidence that reveals the truth. The process might take decades or even centuries, but it does work eventually. The problem is that popular culture and public perception change much more slowly than scientific understanding. People are still walking around with mental images of dinosaurs that were outdated 30 years ago. Museum displays get updated, but movies and books and children's toys often stick with whatever version was popular when they were created. So, the next time you see a prehistoric creature in a movie or a museum display, remember that there's a decent chance some future scientist is going to look at that reconstruction and laugh until their sides hurt. Because if there's one thing we can learn from the history of paleontology, it's that we're probably getting at least half of everything completely wrong. And honestly, that's kind of exciting. It means there are still incredible discoveries waiting to be made, misconceptions waiting to be corrected, and entirely new ways of understanding ancient life that we haven't even imagined yet. The prehistoric world was stranger, more diverse, and more amazing than any of these mistaken reconstructions could ever capture. And we're still just scratching the surface of understanding what life on Earth was really like millions of years ago. But perhaps the most spectacular example of scientific stubbornness involves a creature that managed to confuse researchers for an entire century, not because of missing bones or backwards assembly, but because nobody could agree on something as basic as what it ate for dinner. Meet the mighty Deinonychus, a dinosaur that should have revolutionized our understanding of prehistoric predators the moment it was discovered. This thing had sickle-shaped claws longer than kitchen knives, razor-sharp teeth designed for slicing flesh, and a body built like a prehistoric missile. Everything about it screamed apex predator. But when paleontologist John Ostrom first described Deinonychus in 1969, the scientific community wasn't ready for what he was suggesting. For over 100 years, everyone knew dinosaurs were slow, stupid, cold-blooded lizards that dragged their tails behind them like oversized iguanas with attitude problems. Ostrom looked at Deinonychus and saw something completely different. This wasn't a sluggish reptile. This was a highly intelligent, warm-blooded killing machine that could probably outrun a modern cheetah, while simultaneously disemboweling its prey with those terrifying toe claws. The scientific establishment basically told him he was crazy. Dinosaurs don't hunt in packs. Dinosaurs don't have complex social behaviors. Dinosaurs definitely don't leap through the air to attack prey like some kind of prehistoric ninja warrior. That's just not how reptiles work. Ostrom spent decades fighting this battle, presenting evidence that Deinonychus was fundamentally different from every other dinosaur reconstruction anyone had ever seen. He pointed to the bone structure, the joint articulation, the obvious adaptations for high-speed pursuit hunting. Nobody wanted to listen. It took another 20 years and the discovery of multiple Deinonychus skeletons found together before the scientific community finally admitted that maybe, just maybe, these dinosaurs were actually sophisticated pack hunters with intelligence levels that would make wolves jealous. And even then, it took Hollywood to really change public perception. Jurassic Park turned Deinonychus into a household name, except they called it Velociraptor because that sounded scarier, which created a whole new set of scientific misconceptions that persist to this day. But at least Deinonychus was a real animal that actually existed. Let's talk about the phantom dinosaur that haunted paleontology textbooks for 50 years, despite never having existed at all. Picture this scenario. You're a paleontologist in the early 1900s, and you've just discovered what appears to be a brand new species of duck-billed dinosaur. The skull is different from anything you've seen before. The body proportions are unique. This is clearly a major discovery that's going to make your career. So you publish your findings, give it a scientific name, and watch as your new dinosaur species gets included in textbooks and museum displays around the world. Congratulations! You've just added to humanity's understanding of prehistoric life. Except there's one tiny problem. Your new dinosaur doesn't actually exist. What you've discovered is a juvenile specimen of a species that was already known to science. Baby dinosaurs look completely different from adults, but nobody figured that out until decades later. This happened over and over again in early paleontology. Scientists would find young dinosaurs, assume they were new species because they looked so different from the adults, and create entirely fictional creatures that existed only in scientific literature. One of the most famous cases involved a dinosaur called Nanotyrannus, which was supposed to be a miniature version of T-Rex. For years, paleontologists debated whether this was a separate species or just a juvenile Tyrannosaurus. Museums built displays showing both creatures side by side. Kids learned about the tiny tyrannosaur and its giant cousin. Recent analysis strongly suggests that Nanotyrannus was just a teenage T-Rex going through its awkward adolescent phase. All those supposed differences between the species were just normal growth changes. We basically spent decades studying dinosaur puberty and calling it evolutionary diversity. But phantom species pale in comparison to the dinosaur that was literally built from spare parts. Imagine walking into a paleontology lab and finding a box full of random fossil bones. Vertebrae from one animal, leg bones from another, skull fragments from a third. Any reasonable person would assume these came from multiple different creatures that died in the same area, not the scientists who created Proto-Ovis. They looked at this collection of mismatched bones and decided they'd found the earliest known bird, a creature that would revolutionize our understanding of avian evolution. They published papers, gave lectures, and basically declared that the origin of flight was 75 million years older than anyone had previously thought. The only problem was that detailed analysis revealed the bones came from at least 5 different animals, none of which were birds. The skull belonged to a small dinosaur, the legs to another dinosaur, some vertebrae to a pterosaur, and various other fragments to creatures that hadn't even been properly identified yet. It was like finding bones from a chicken, a lizard, a bat, a mouse, and a turtle, then announcing you'd discovered a new type of flying mammal. The scientific community eventually figured out the mistake, but not before Proto-Ovis appeared in countless research papers and textbooks as a genuine transitional fossil. And speaking of transitional fossils, let's discuss the missing links that weren't actually missing anything. For decades, paleontologists complained about gaps in the fossil record. Where were all the intermediate forms showing how one type of animal evolved into another? Evolution predicted they should exist, but the fossils weren't cooperating. This led to some truly creative interpretations of incomplete specimens. Scientists would find a partial skeleton, notice that it had characteristics of two different groups, and declare it a transitional form. Museums would build entire exhibits around these supposed evolutionary bridges. The problem was that many of these transitional fossils were just regular animals that happened to share some features with other species. When more complete specimens were discovered, it became clear that these weren't evolutionary intermediates at all. They were just members of diverse groups that happened to look similar because of convergent evolution. It's like finding a dolphin fossil and declaring it's the missing link between fish and mammals because it lives in water and has fins. The superficial similarities don't actually indicate evolutionary relationship. But if you only have partial information, it's easy to jump to the wrong conclusions. But sometimes the problem isn't incomplete fossils. Sometimes scientists have all the evidence they need and still manage to get everything spectacularly wrong. Take the case of the armor-plated dinosaur that wasn't actually armored at all. Paleontologists discovered what appeared to be a heavily defended herbivore covered in bony plates and spikes. The fossil preservation was excellent. Every detail was clearly visible. This was obviously a walking tank designed to protect itself from predators using prehistoric body armor. Museums created dramatic displays showing this dinosaur surrounded by hungry carnivores, its armor deflecting attacks while it peacefully munched on vegetation. Nature documentaries featured epic battles between armored herbivores and frustrated predators who couldn't penetrate their defenses. Turns out the armor plating was actually just the fossilized remains of the creature's last meal. The bony plates were fragments of other dinosaurs that this supposed herbivore had been eating when it died. Those defensive spikes were actually broken teeth and bone fragments from its prey. So we went from imagining a peaceful plant eater with natural body armor to discovering an aggressive carnivore that was literally caught red-handed in the middle of devouring other dinosaurs. The exact opposite of what everyone had assumed for decades. This kind of mistake happens more often than you'd think, because fossilization is a weird process that can preserve things in unexpected ways. Stomach contents can shift around and end up looking like body parts. Bones from different animals can get jumbled together. Minerals can replace organic material in ways that completely change how fossils appear. And sometimes the preservation is so good that it actually creates more confusion. Scientists recently discovered dinosaur fossils with what appeared to be perfectly preserved feathers, skin, and even internal organs. The detail was incredible, better than anything paleontologists had ever seen before. But detailed analysis revealed that most of these soft tissues were actually bacterial films and mineral deposits that had formed during fossilization. The bacteria had eaten the original organic material and left behind structures that looked exactly like feathers and skin under certain types of microscopy. This created a brief period where paleontologists thought they'd discovered the secret to perfect fossil preservation, only to realize they'd been studying ancient bacterial mats instead of actual dinosaur biology. It was like thinking you'd found a perfectly preserved ancient human, only to discover you were looking at a really detailed scarecrow. But even when the fossils are genuine and the preservation is legitimate, scientists can still manage to misinterpret evidence in truly spectacular ways. Consider the dinosaur tracks that supposedly proved giant predators were stalking herds of peaceful herbivores across prehistoric landscapes. Paleontologists found a trackway showing large carnivore footprints following smaller herbivore prints for hundreds of feet. The story seemed obvious. Here was direct evidence of predator-prey behavior preserved in stone. You could practically see the chase scene playing out millions of years ago. Museums built entire exhibits around these trackways, complete with dramatic lighting and sound effects to simulate the prehistoric hunt. Scientists wrote papers about dinosaur hunting strategies based on the spacing and depth of the footprints. But more detailed analysis revealed a completely different story. The tracks weren't made at the same time at all. The herbivore prints were made during one season when the ground was soft and muddy. The carnivore tracks were made months later when the sediment had dried and hardened into a different consistency. There was no chase scene. There was no predator following prey. There were just two different dinosaurs walking across the same patch of ground at completely different times, like finding your footprints and your neighbor's footprints in the same sidewalk and concluding you were chasing each other. This kind of temporal confusion happens all the time in paleontology because geological time is so vast that events separated by thousands of years can appear to be simultaneous in the fossil record. It's like trying to understand human history by looking at a photograph that somehow captured images from every century all at once. And that brings us to one of the most persistent myths in dinosaur paleontology, the idea that these creatures lived in a world of constant violence where only the biggest and most heavily armed species could survive. This red in tooth and claw interpretation dominated scientific thinking for generations. Every new dinosaur discovery was interpreted through this lens of prehistoric warfare. Herbivores were covered in defensive armor and weaponry. Carnivores were described as unstoppable killing machines. The entire Mesozoic era was portrayed as an endless arms race between predators and prey. But this interpretation says more about human assumptions than it does about actual dinosaur behavior. Scientists were projecting modern ideas about nature being violent and competitive onto ancient ecosystems without considering that prehistoric life might have been more cooperative and diverse than anyone imagined. Recent research suggests that many dinosaurs lived in complex social groups with sophisticated communication systems. They cared for their young, migrated in organized herds, and probably spent most of their time doing normal animal things like eating, sleeping, and socializing, rather than fighting epic battles for survival. The heavily armored herbivores probably used their defensive features more for display and species recognition than for actual combat. Those elaborate crests and frills were likely colorful signals for attracting mates and establishing social hierarchies, not weapons for desperate last stands against hungry predators. Even the fearsome carnivores were probably more like modern big cats than prehistoric monsters. They spent most of their energy hunting smaller prey, scavenging when possible, and avoiding unnecessary conflicts that could result in injury. A wounded predator in the wild is usually a dead predator, but the warfare interpretation was so compelling that it influenced how paleontologists approached every new discovery. Any unusual feature was immediately classified as either offensive or defensive weaponry. The idea that dinosaur anatomy might be related to social behavior, environmental adaptation, or sexual selection was largely ignored. This created a feedback loop where scientists kept finding evidence for prehistoric violence because that's what they were looking for, while missing signs of cooperation, intelligence, and complex behavior that didn't fit the established narrative. And the most frustrating part is that changing these entrenched ideas takes decades, even when the evidence clearly points in a different direction. Scientific paradigms are like massive ocean liners. They eventually change course, but it takes an enormous amount of time and energy to overcome their momentum. Meanwhile, popular culture keeps recycling outdated scientific ideas because dramatic battles between giant monsters make for better entertainment than accurate depictions of complex prehistoric ecosystems. Movies and documentaries from decades ago still influence how people picture dinosaurs today. So we end up with a situation where the general public's understanding of prehistoric life is based on scientific theories that were abandoned by researchers years or even decades ago. It's like everyone's still believing the Earth is flat because that's what the maps looked like in elementary school. But here's the thing that makes all these mistakes and misconceptions somewhat forgivable. Paleontology is essentially detective work, except the crime scene is millions of years old. Most of the evidence has been destroyed, and the clues are scattered across multiple continents and buried under tons of rock. Scientists are trying to reconstruct entire ecosystems based on fragments of fossilized bone, occasional preserved footprints, and educated guesswork about how ancient environments might have functioned. It's like trying to understand modern human civilization by examining a few scattered artifacts that survived some catastrophic event. Given those constraints, it's actually remarkable that paleontologists get anything right at all. The fact that we can look at a 100-million-year-old fossil and make accurate predictions about how the animal moved, what it ate, and how it interacted with other species is genuinely impressive. But it's also important to remember that our current understanding of prehistoric life is still incomplete and constantly evolving. Every new fossil discovery has the potential to revolutionize how we think about ancient ecosystems. Techniques that don't exist yet will probably reveal aspects of dinosaur biology that we can't even imagine today. The creatures we've been discussing represent just a tiny fraction of the biodiversity that existed during Earth's long history. For every dinosaur species we've discovered, there are probably dozens or hundreds that lived and died without leaving any trace in the fossil record. And even the species we do know about are often represented by just a few bone fragments or partial skeletons. We're making educated guesses about their appearance, behavior, and ecology based on extremely limited evidence. So while it's entertaining to laugh at the mistakes of past paleontologists, it's worth remembering that future scientists will probably find our current reconstructions just as amusing. The difference is that we now have better tools for analyzing fossils and more sophisticated methods for testing our hypotheses. But we're still working with the same fundamental limitations that have always challenged paleontology. The fossil record is incomplete, preservation is unpredictable, and extinct ecosystems operated according to principles that we're still trying to understand. What we do know for certain is that prehistoric life was far stranger, more diverse, and more amazing than any Hollywood movie or museum display could ever capture. The real ancient world was filled with creatures so bizarre that if we saw them today, we'd assume they were the product of someone's overactive imagination. And that's what makes paleontology so fascinating, despite all its mistakes and misconceptions. Every fossil discovery is a window into worlds that existed long before humans evolved. Ecosystems that operated according to rules we're still figuring out, and evolutionary experiments that produced solutions to survival challenges we've never encountered. The errors we've discussed today aren't failures of the scientific method. They're reminders of how difficult it is to understand the deep past and how much we still have to learn about life on Earth. But they're also testament to the self-correcting nature of science. Every mistake eventually gets identified and corrected as new evidence emerges and analytical techniques improve. The process might take decades, but it does work. And in the meantime, we get to enjoy the spectacle of brilliant scientists getting prehistoric creatures so completely wrong that their mistakes become more entertaining than the actual animals ever were. Because sometimes the journey toward understanding is just as interesting as the destination. So there you have it. The greatest hits of paleontological failure, a collection of mistakes so spectacular they make your worst school project look like a masterpiece. From backward sea monsters to fruit-eating apex predators, from giant swimming turtles that were actually feathered dinosaurs to whale kings that got stuck with reptile names forever. But here's the wild thing. Every single one of these embarrassing blunders eventually got corrected because that's how science actually works. Someone always comes along with better tools, fresh eyes, or that one piece of evidence that makes everything click into place. It might take decades or even centuries, but the truth has a funny way of surfacing eventually. The problem is that scientific corrections don't make headlines like the original discoveries do. Popular culture moves slower than research, which means people are still walking around with mental images of prehistoric life that scientists abandoned years ago. That subway mosaic of the cannibal dinosaur is still there. Kids are still learning about lazy, swamp-dwelling giants. Hollywood keeps making movies about creatures that never existed, the way they're portrayed. And honestly, that's what makes this whole thing so fascinating. We're definitely making similar mistakes right now with fossils sitting in museums around the world. Future paleontologists are going to look at our current reconstructions and laugh until their sides hurt, just like we're laughing at Victorian scientists who thought whales were sea serpents. The prehistoric world was stranger, weirder, and more incredible than any of these mistaken reconstructions could ever capture. And we're still just scratching the surface of understanding what life on Earth was really like millions of years ago. Which means there are still amazing discoveries waiting to be made, misconceptions waiting to be shattered, and entirely new ways of seeing ancient life that we haven't even imagined yet. So, the next time you're staring up at a dinosaur skeleton in a museum, just remember there's a decent chance that some future scientist is going to completely revolutionize how we understand that creature. Because if there's one thing we can learn from the history of paleontology, it's that we're probably getting at least half of everything completely wrong. And that's actually pretty exciting when you think about it.